Hey everyone, welcome back to another episode of Mrs. Tech Talks. And we have a very special guest today, Anand, joining us. Hey Anand, how are you?
Hey, thank you for having me.
Glad to have you. And Sonu, our co-host. Hey Sonu, how are you?
I'm good. How are you guys?
Ah, doing great. I don't know, like I have suddenly have a lot of work to do. So it's hard to get some time. I don't know, something changed from here.
I think everyone is back from the holidays, right? And it's like time to get started. The year just got started, basically, right? In February.
That might be true. But yeah, today we are going to talk about a very interesting topic. It's about LLMs and prompting because this is something which has been talked a lot in the developer community, right? I mean, people are worried like AI will take the job. And what are LLMs? Like everyone is wondering what are LLMs and why suddenly everyone is an AI engineer or why people are saying that everyone should be an AI engineer. So we got like one of the best Anand with us here talking about or sharing like what is LLM and why you should care about it and what is prompting. So before we go ahead and talk about this, Anand, would you like to introduce yourself?
Absolutely. Yeah. Thank you so much for having me. My name is Anand. I am engineer, designer, tech founder. I run First Quadrant, which is an AI sales platform funded by Y Combinator. We help companies grow faster by automating a lot of the tasks that traditional salespeople have to do, like prospecting customers, qualifying leads, sending out emails, answering questions, stuff like that. And we use LLMs to build the entire product. So it's like an AI first CRM that we've built on top of LLMs. So I've been, using LLMs for a few years now, just like everyone else. And it's a really exciting space. Every morning I wake up and it's like I have to catch up on what has happened between yesterday and today. And it's really exciting. I know Santosh from the GitHub Stars program, where we both have been for several years now, which is because I also do some open source stuff on the side. So yeah, I'm just really happy to be here.
Glad to have you and congratulations on getting your star award for 50 years. So yeah,
You as well, man.
before we jump into like of course all the advanced stuff, and I'm sure like people have all the developers now have like okay a little bit idea about LLM. So we'll not talk about like very basics, but let's start with like how actually LLM works, the magic behind it.
Yeah. I mean, we've all used LLMs probably already now, right? Because it's basically like having autocomplete, but at massive scale, right? And I think we all understand that, like, fundamentally, they are next token prediction machines. I think the way to think about it is I think tokens are words or parts of words. So let's make it easy and say, okay, words, right? So just like autocomplete, a large language model just predicts what should be the next word based on what has happened before it. And it just does this through patterns that it's learned over vast amounts of text. So the LLMs that we use today, like GPT-4, have all of humanity's knowledge, all of the internet essentially scraped, and then it recognizes patterns. And then from that pattern recognition, it can just predict what would be the next word. And the key insight was if you can predict the next word, just the next one word after a paragraph, for example, you might type in Michael Jordan plays, and then the next word, it can predict basketball because it knows that from its knowledge. You could then run that loop again and then predict the next word and then keep doing this. And essentially, you go from next word prediction to text generation because text generation is just predicting the word over and over again. So that was really simple. Slightly more interesting is the actual architecture. They use something called transformers with attention heads. The way you think about it is they're components that can identify word relationships that are important. So words like, I don't know, well can be used to say, I'm taking water out of a well, or I can say, well, isn't that interesting? And so the idea is that it doesn't just take the word, it also identifies what does that word mean in that context. So to make all of this happen, a model converts these words into vectors, which are just numbers where similar concepts are similar numbers. So the way that I like to think of it is really fun. There was a video from 3Blue1Brown on YouTube where he said a really good way to think about embeddings is that if you take the embedding for king and you take the embedding for man, and you take the embedding for queen and you take the embedding for woman. And you can see that there would be a relationship. If you take the embedding of king and subtract the embedding of man and add the embedding of woman, you would get to a number very close to the embedding of queen, meaning that, let's say, royalty is something that it understands as a concept, and gender identity is something that it understands as a concept. And so LLMs just do this with billions of parameters. Parameters are connection points that store all of these learned patterns. And through neural networks, through many, many layers with increasingly complicated patterns, you scale it up and it just next token prediction becomes intelligence at one point.
That's a very good way to actually summarize this. Thanks for that introduction. So, what's your experience with LLMs? Have you been working with them?
Yeah, so LLMs are really exciting. So we started first quadrant right before ChatGPT was launched. So we were in the days of GPT-3 back then, which seems like forever ago, but actually is like 2 years ago. It's been like dog years basically in the industry now, right? Like we've had like every year we have like 10 years of progress. So it's just crazy. So we use LLMs for the entire product in my day job. So we thought that, hey, if these models are good at reasoning and decision making and kind of thinking, whatever that means now, what if we could make the tasks that people have to reason for and think for and automate those? And so we built a product where a lot of this stuff that you would have to do happens automatically. Like if somebody asks you a question like, what's your pricing? The LLM would think that, okay, so they're asking a question about pricing. So let me vector search the knowledge database and figure out pricing information. And then I would, okay, so now I know that this is the pricing, this is the company size, so they would be in this plan. So then I can write an email saying, hey, this is our pricing. And if they don't reply, I should set up follow-ups. So just by having a question like, what's your pricing? It can write a whole chain of email replies to send out to their answer. And so to make this happen, we use a ton of different prompts and chains and agents and everything. So it's really exciting because when it all comes together, it really does feel like magic. It's like, whoa, how did that just happen? But if you break it down, it's just a lot of vector multiplication. So it's really, really fun that from multiplying vectors, you get to this kind of almost magic-like experience.
Yeah, totally can relate. Like, so for the first time when everyone probably as a developer used Copilot, right? I mean, that was like magic, and where
Yeah,
everyone were like, "Wow, what's
absolutely.
this is magic!" And then, of course, now there are so many other models. But
Yeah,
yes,
and
so over to you. Like, how was your experience with the LLM so far?
I haven't really used LLMs a lot, to be honest, you know. So it's actually good to understand from Anand what LLMs are. You know, I really have very limited knowledge on this, but it's great to hear it. I have a follow-up question though, you know. Certainly AI, you know, isn't something new. It has existed for a long time. And just recently with, I guess, ChatGPT and everything, every other like service that has AI offerings, you know, how has LLMs evolved over the past few years?
yeah, like I said, it's actually been like a crazy evolution if you think about it. Like from so the earliest models that I remember, GPT 1, 2, 3, were just simple text completion. And now the most recent models that we have, let's say O3 Mini or DeepSeek, are they have very complex reasoning ability. So how it started was there's really been this exponential growth of like let's say in terms of patterns. So GPT-2 was like between 1 and 2 billion parameters, and then you think, okay, so GPT-3, let's say you go from 1 billion to, I don't know, 100 billion. So GPT-3 was almost 200 billion parameters, so it's like crazy growth. And then GPT-4 is over a trillion parameters already. So we had this knowledge for basically that you can scale to a better model. And so they call this a scaling law. And for the last few years, let's say 3 years, it's really been like a new Moore's law that you could just add more compute, train a bigger model, and it's going to just be a smarter and a better model. In the last half a year or so, the industry wisdom has kind of changed that we discovered this scaling law, but we're kind of hitting a plateau that bigger may not always be better. And so now we have a new scaling law for runtime compute, with reasoning, with the idea that maybe you don't have to just scale the training, you can scale the time that the model has to actually think about things. But so basically, the evolution few years has really been that exponential growth in the number of parameters. And how that works under the hood is you just train on all of the data, and then you introduce RLHF, which is training using human feedback. It stands for reinforcement learning through human feedback for better alignment. So the idea that the model actually does what you want it to do. That just means you take the base model and then you give it a lot of examples of, if I say this, you should say that. And it can learn from that. And then when it actually does something right, you tell it that, hey, you did this right. And then, of course, there's a lot of, specialized techniques for there's a lot of other cool stuff happening in AI also, apart from just LLMs in the last few years. But I think there's been a lot of improved efficiency in training, in deployment. There's been a lot of safety. There's been even ethical consideration. So there's like a lot of cool stuff that has happened in evolution. I think the last thing I'll just say is the most interesting new thing that has happened with O1, where the paradigm kind of changed to reasoning, with the idea that we've always had this idea of like chain of thought, that let's ask the model to actually think step by step before giving me the final answer. Because if you think about it, that's also how humans do. Like, if you ask me something, I'm not just going to say the first thing that comes to mind. I'm actually going to think about it and then say, okay, this, and then this. And so therefore this. And so with O1, that paradigm really opened up, where it's before we had to kind of prompt the model and say, hey, just take a step back, take a deep breath, think step by step. But now with RLHF, OpenAI actually trained the model to always do the chain of thought first. And so the results are much better. So that's also been a really exciting thing in the evolution, really the last thing now. And so I think personally, this is something that we can now scale again. So if we kind of broke the scaling law of the exponential growth of parameters, now we can have a new scaling law for reasoning ability by the LLM knowing how long to spend on something, and it can dynamically think of that. And personally, just sci-fi, I also think we can really optimize this even on a hardware level, like just like in terms of the bytes and the electricity and the power and how many NVIDIA GPUs you're using. I think if you ask, what is the capital of India versus please discover new physics for me, I'm sure there is something there. We haven't figured that out just yet, but I think the idea that maybe we can even have some sort of dynamic compute combined with dynamic reasoning abilities, I think will be like a brand new scaling law where, I don't know, to be honest, like if you just look at what has happened in the last 1 year, I don't even think I can reasonably predict what would happen a year from now, just because it's such an exponential curve that we're on right now.
Makes sense. I mean, a powerful model every other week now. It's just like we used to have every week there used to be a new framework. Now there's a new model in the market.
Yeah. And as Santosh said, like Copilot, like we were one of the first people in the world who used GitHub Copilot because of the STARS program. And it was just so exciting because for the first time we had this pair programmer who's always there, who can autocomplete. And I always say this, I find this so fascinating that I don't think I've become a worse developer. I was really lucky that I was able to like code before AI happened. And so I already know the things. People are talking so much about like what would happen to the next generation of developers. I don't think we're doomed. But what always happens is whenever I'm taking long flights, like let's say from San Francisco to Amsterdam, and I don't have Wi-Fi, I just download everything, before so that I can continue working in the plane. But then like when I'm typing, especially when I'm writing code, I would type something and then I would just wait for a second. My brain would actually buffer because I'm waiting for the autocomplete to happen. And then it hits me like a second later that, oh, it's not going to autocomplete. I have to type in the entire line. And so Copilot is like, you just start to rely on it and it's like part of you. And now with, for example, for the over a year now, I've been using Cursor, which is like Copilot, but kind of on steroids because it doesn't just do autocomplete. It also like puts your cursor in the right place and it's like really smart. So I think that's really like the biggest evolution we've seen, right? Like in how Santosh knows, like how we used to write code 2 years ago is just so fundamentally different than how we build products today that I don't even know what it's going to be like in 2 years from now. But like, I'm so excited that like we get to kind of experience this.
Just think about the time as a developer when we used to write the code on Notepad++, right?
Oh my
There's
God.
no ID, no autocomplete. And then autocomplete came, better ID came, and now it's like you don't have to even think about like, of
Yeah.
course, there's some time you get a garbage code, like does not exist, but it's part of the learning process. But think about like how much easy it is to actually write new code.
Yeah, absolutely.
So let's move on to the next part, right? Of course, I have spoken to some of the AI experts, and one thing which I always keep hearing is like, of course, you have LLMs, right? But to use LLMs, you have to be good at prompting. Otherwise, like, it will be hard. Like, you will always end up with some junk data. So when we talk about prompting, it's of course giving instructions, right? So what do you think like are the most effective prompting techniques when you have to work with LLMs?
Yeah, so you can really go deep into this because like on Reddit every week there's like a new idea of like, oh, let's do this. I remember like a year and a half ago it was like you should type in I will give you $100 tip, and it would give the right answer more often than if you don't give it a tip. And then people started typing, I'll give you $1,000 tip. I'll give you a $10,000 tip. There was even a study that did this and decided what is the best tip amount to offer to GPT to get the right answer. Or people would say, if you don't do this, my grandma would die. And it would actually give the answer correctly more often. Because if you think about it, it's just learned on what people do. And people like tips and don't like grandmas dying. And so it just knows that, oh, I should give the answer more often. It's just something it knows, right? So luckily, we're not there anymore. Through the last few years of RLHF, we've built much more aligned models. So I gave a whole talk last year for like an hour on like prompting techniques. But I think depending on the model you're using, a chain of thought still works really well. You don't need to do it anymore when you're using a reasoning model, but for traditional models, even for example for Claude, for Sonnet, for 4o, asking the model to show their reasoning steps always helps. So, depending on the kind of work we have, we sometimes say first respond with a step by step process and then give the answer rather than just asking for the answer. Another way to do this, if you don't use chain of thought, is at least using reasoning. So you can also prompt the model to say, respond in this format, first give me a reasoning and then give me the answer. That's also a really cool thing. So let me give you an example. We receive at first quarter a lot of times an email reply where somebody's out of office. It's just an automatic out of office email. And so first quarter is smart enough to know, oh, this is an out of office email. So that means the email that I sent them out, let's say I sent them my pricing and I got an out of office, they probably haven't seen this yet. So I shouldn't just reply to this out of office email now. So then the question is, when should I reply to it? And so it can read the email. Let's say somebody says, I've gone for the holidays. Then we use an LLM to decide what is the follow up date based on this email, because the LLM is smart enough to know, okay, today is, let's say, December. And so the holidays means they'll probably be back in the first week of January. And so if we leave a few days buffer, maybe we should follow up on the 10th of January. Let's say that's what the LLM comes up with. So if I would just say, look at this email, when should I follow up? It might say something which might not be very well thought of. But if I say, actually, reason, give me a paragraph for reasoning, and then give me the answer, it would actually output, let's say the sender is out of office right now. The holidays typically refers to this Christmas holiday period. They'll probably be back on the 1st of January or the 2nd of January. So leaving a few days, maybe we should do 10th of January. And so because of how LLMs work, as we established, they're just next token prediction machines and they learn from the previous tokens. So if you ask the model to reason first, then the answer will also have that reasoning as the thing based on which it predicts the answer versus just the question. And so chain of thought works really well. Of course, like, having like base behavior rules or format patterns in system prompts are helpful. Structured outputs are always very helpful, especially in my kind of business where you want the LLM to not just write creatively like emails, but also make these decisions like, should I unsubscribe somebody or when should I follow up? I always want the exact right format. And so you can use like JSON, for example, and say, always respond in this JSON schema. And then for like creative tasks or writing emails or stuff like that, I think there's also a healthy balance of adjusting creativity and predictability with temperature control. And then there are other methods that are not as relevant anymore. For example, few shot learning is one where I remember in the olden days, how we used to write emails is that I would actually give it like many example emails so that it can establish a pattern and then write the next email. But now you don't really need to do much of that as much. Depending on the context, it's still helpful. And then I think one more thing that people usually don't think about in prompting is context management, like the idea that the model does have a context window. And so you don't want to just fill it up with junk. You want to give it only the relevant and important information. But we can double tap on any of them. But I think like really today's models are so smart that it just comes out to writing the right prompt in kind of the right way that the model understands. And this is also like different. Like my prompt for Claude is a bit different from my prompts for GPT, for example, or my prompts for reasoning models are very different from my prompts for non-reasoning models. But I think there are like these established, best practices. But I think if you use like good system prompts, good context, structured outputs, you can get really like serious intelligence out of these models.
So, what do you think are the common pitfalls, for
Yeah, I think
in prompt engineering? Like, how can they be avoided? How can you become better at it, right, to get the result you want?
I mean, prompt engineering is already such a loaded word. And also, I think what's really good is that all of the things that were pitfalls before are only getting less falling, less pitting, like less deep, because these models are only getting better and more aligned. But I think basic, I would say, it depends on the task. You don't want to be too vague or assume a lot of knowledge, right? Like if it's like a student and you're a teacher, but it's a very literal student, the way you would ask it to do something is to maintain kind of like a stability in the prompt, right? So like you have the same structure with different examples, you give it like output formats, you give it like a plan for handling failures. If you have a complex chain and one thing fails, what should you do there? So I think probably the main pitfalls are just writing a very open-ended prompt where you can get a lot of diversity in output, not defining validation. So like either not having structured data or at least having like kind of like a success criteria of sorts. Like how does the model know what does the right answer look like? So like what kind of format do you want? How long do you want it? Stuff like that. I think efficiency can be helpful, especially at scale. Like it's not necessary that if you have like 20 examples in a really long prompt, it's going to do a better job when if you just have the basic format and you let it reason. So I think there's always a healthy balance on like how do you optimize also the prompt space usage, because of course costs and they add up, especially on scale, but also we've learned this that too much context and too much information can also be overwhelming. Just like with a person, right? Like if you give them a whole book and say, what is the answer to this question? Versus if you give it the exact right chapter, you would do a better job. And then I think something people don't think about too much is just bias control. Like how do you make sure that it doesn't bias to any recent examples that you gave it? Like, so for example, whenever you include examples, let's say we have a classification system, always include diverse examples. So like if you have an example for just positive, maybe when it comes up with a negative answer, then it's a bit biased because you told it what positive is like. So either you give it like very different examples so that it can establish the difference and the diversity, or you give it like no examples and just one shot it by giving the response format in a descriptive way so you still get the output. But I think, yeah, if you don't make it too vague, too detailed, don't assume too much of the context, and not like overcomplicate the prompt also with like very specific instructions. Just kind of vibe it. I think you're going to do a good job.
Another follow-up question related to prompting is we have been hearing about a lot recently. I think it started around last year, RAGs, right?
Mm-hmm.
So, which is retrieval or augment generation, right? Does it full form? Because when I heard RAG for the first time, I was like, what is this now? I mean, I was just learning about the full form of LLM. Now there is a RAG. So, what is RAG and how it is improving the LLM or prompting techniques?
Yeah, good question. So, yeah, as you said, drag, it's in the name, right? You retrieve something to augment the generation. In fact, I found out about RAG as a concept from Ahmed, our also fellow GitHub star, who's the founder of Langbase, which is an AI language tooling app that I'm an early investor in. Really smart guy. And he told me about it and explained it to me in a really nice way. So, the idea is that the models have their own knowledge, right? They have the knowledge of the world, but they don't have your specific knowledge, right? Of course. So if you want to, let's say if you're building a lawyer AI that is very good at writing immigration forms, then you can just prompt it. You can just say, write this immigration form, but maybe it needs like very specific industry knowledge or like a format or something other than that. So you add this into context, right? So in the prompt, you say, use this information to try to do this. So RAG is the idea that you want to give the model access to very specific knowledge so that it can base its answer on that information. So, for example, Perplexity is a search engine. And how does it work under the hood? If you ask, what is the capital of India? It can either just be offline and the model can just answer. It's going to say New Delhi because it's an obvious thing. But if you ask, what is Santosh's last name? Maybe that is not information that the model knows exactly. So you want to do a web search. So maybe you would do a web search on a traditional search engine like Google. You would go to a few websites. Let's say you go to santoshyadav.dev. You go to the about page and you get the information. And then now you will give this information to the model in the context. So in the prompt, say, what is Santosh's last name? Please use the following information, and you copy paste his whole website. And then when the model responds, it's going to use its own knowledge, but also the knowledge that it just learned from the website and say, his last name is Yadav. And so there's a lot of techniques on how do you now optimize this process. It's just a fancy term, to be honest. You don't even have to use the word RAG. Not many people do anymore because it's just overcomplicating the idea that just give relevant knowledge to the model to answer the question. So to do RAG, there's a lot of cool stuff. There is vector search, meaning that you take, let's say, Santosh's entire website, you chunk it up, so you break it up into pages like about, and then you break each paragraph up, and then you create embedding. So you create those same numbers of each paragraph, so that when I ask the question about his name, we can just do a traditional search to see the most relevant numbers, and then only select the right paragraph, maybe from his about page, and then only put that in the prompt rather than having to put his entire website. And then you can take it a step further. So vector search uses like trigonometry to come up with the most relevant paragraph, for example. You can do hybrid search, which combines just traditional keyword search with like semantic matching. You can do a bunch of different techniques from your vast library of information, get the right thing that can help the model try to answer it. And then the idea of breaking it down into paragraphs, it's called chunking. It doesn't have to be a paragraph. It can be a sentence or a whole page. So you can, play around with how big do you want each chunk to be? How do you add real-time updates, for example? How do you keep the knowledge current? How do you add sources and citations? Something Perplexity does really well so that the model can actually say, this is the source. So RAG is just this general idea of like giving the model this specific knowledge, but then there's a lot of really exciting techniques that can be used to give it the right knowledge and ask the model to reply with it in the right way. The good thing is there's a lot of really good frameworks. So for example, Langbase has their own memory feature and their own like data sets feature. If you want to use web search, Perplexity just released their own model 2 weeks ago called Sonar, which actually has access to web search. So now you can just use the API to ask a question. I would use web search and RAG it yourself. And then if you have your own proprietary knowledge, like let's say your company database or docs and stuff, and you want to build a chat, you can just use traditional and vector search to find the relevant knowledge article, give it to the model, and then ask it to answer the question. And so in the live chat, for example, if a customer asks, how do I reset my password? The model doesn't hallucinate. It doesn't just think of something from randomness. You can maybe give it the right help desk ask article related to user accounts. And then from that, it can answer the question. So RAG is just this general idea that with specific knowledge comes more accurate responses. And then there's a world of techniques that have been perfected over the last like year and a half that just helps you optimize the knowledge you give the model so that you can get the right answer.
Talking about real world examples, tuning has significantly improved the outcome or the result.
Yeah, so I think prompt tuning is definitely a big thing because, of course, it's prompt engineering after all. But yeah, in general, I think the future we're kind of moving towards a more intuitive, a more efficient model usage, right? Like, so the models are much more aligned now than they were a few years ago. I think in terms of general future trends, I think there's a lot of cool stuff happening. For example, my co-founder Carlo has this idea of like self-improving prompts. So like when we do something in first quadrant, right? Let's say we make a decision and we write an email, our customer can overwrite that so they can just change the email content. And then what we can do is we can take this information that it's not an explicit signal like a thumbs up, thumbs down. It's just fact, right? It's just information. It's just an implicit signal that the customer changed the email. And then maybe we can take this information and think, why did they change this email? What did we do wrong? And then we can take the current prompt, take the old email and the new email and understand what they changed, and then use that information to improve the prompt for that customer. So this idea of self-improving prompts, I think, is a really cool future trend. We are really starting to think about this deeply. Of course, like, there's a lot of cool stuff happening in RAG, there's a lot of cool stuff happening in multimodal, so now you cannot large language models, but these models are multimodal now. So they don't just handle text, they can also handle code, images, music, even video, stuff like that. That's really cool. As we talked about earlier, I think reasoning is a huge new frontier of future trends. We're just getting started. We did jump from O1 to O3, but we're nowhere close to, I think, the limits of kind of scaling reasoning. So that's really cool. I think integration is really important, right? Like with RAG, I think to get the best usage, you also want to integrate it to, let's say for us, like the databases, the APIs, the CRMs of the world, and so on. So I think tools integration is a general cool thing. And I think the last thing, which I'm the most excited about, is small models. Like we have this idea that you don't just have to have the hugest models, you can create small fine-tuned models from big models, which would be really good at doing a very specific thing. So the efficiency would be really high and the cost would be really low. So for example, Microsoft has this model called Phi, and now there is this technique called distillation with which you can, for example, take a llama and then use a O3 mini and take the outputs of the O3 mini to fine tune a llama so that the llama can that let's say be really, really good at email classification. So it wouldn't be very good at everything else, but it might be like 10 or 100 times cheaper than using the big model for this specific task. So I think this idea of like parameter efficiency, let's call it, like the fact that those parameters are more important for that model. So you can basically do a lot more with a much smaller model. I think that's the future trend that we're going to see a lot, right? Like now my iPhone runs its own language model. And so I think as we get to this idea of having very good small models, we're going to see them everywhere. We're going to see like all of your devices having their own models, and they don't need to just run big foundation models. They can just run specific models for specific tasks.
I just learned so much in 10 minutes, last 10 minutes.
It's a lot of information to digest, I think.
You should use an LLM for that.
Yeah, good. So I think we are done with most of the questions. Thanks again for like giving us time and sharing so much knowledge about it, about like LLM and prompting. Before we end, we generally ask our guests to actually promote anything. So if you want to promote anything on our channel, please go ahead and do.
Oh, that's so sweet. No, I didn't. I don't have anything prepared to promote. I think open source is amazing. And whoever's watching this, if you were, waiting for someone to tell you to make that first pull request, do that. On GitHub, there is a label called Good First Issue, where open source or like up for grabs, where open source projects just say, hey, this is a good first issue. If you haven't ever contributed to open source, you can get started with this easy issue. So do that, I think I want to promote more people just doing more great stuff. So make that first pull request.
And if you need any help in contributing to open source, reach out to Sonu or me, or even you can reach out to Anand. I will be sharing his contact details, not the personal number, but of course you can reach out to him on social media. Thank you again, everyone, for watching.
And it was really fun.
Thanks again, Anand. Thanks again, Sonu, for joining us. And we'll be back for another episode, and we'll be talking about home automation. So we'll actually that's going to be an interesting topic as well. So let's see. So see you again soon. Bye.
Cheers, guys.